Hello and welcome to this video. In this video, I'll be showing you how to build an AI agent using Pydantic. Using an example, Stackloop, a CLI tool that captures the stack trace within your application and fixes the issues within that particular stack trace. Let me show you the CLI tool in action. All right, so here's the code for the CLI tool, and I'm going to run the command. It's a CLI tool, right? And so this is how you stack. This is how you run the tool. Stack loop, run, pass the path to the project that you want to, find issues in, capture the stack trace, and fix whatever issues are in the stack trace. So it's I'm using Poetry Run because this is the development version. By the time this video is live, the updated version of the Stackloop application will be up as well. So let me show you this particular project first. So here's that particular project. It's a Nest.js project, and it's just a bare bone Nest.js project, nothing really. And I'm going to try to introduce bugs within the project. So LLM will be able, the AI agent will be able to capture those bugs, those issues within the stack trace and fix them. So right, so we have two issues in 2 files. So let me run this and then you'll see it in action. So here's Stackloop version 2.0. The version 1.0 was basically, even though I was using Pydantic, it was basically just using Pydantic and just making LLM calls. It wasn't really taking advantage of all of Pydantic's agentic workflow features, right? So I wasn't taking advantage of tools. I was basically just using Pydantic, pass a prompt, and then just call the LLM and just use the type safety thing within Pydantic to enforce responses and make the responses from the LLM match the response type that I've defined. So that was basically all I was doing using Python. But now it's fully an AI agent, and I'll show you the tools and everything that I did within the code. But let me just show you the tool in action. So here, Stackloop is running. I select the provider. I'm using Grok, and then I'm using these models within Grok. So I'm using OpenAI, and then that particular project is an Nest.js project, so Node, JavaScript. So the command is npm run build. I'm using npm run build because npm run build would build the application and exit. So in that way, once it exits, I'm able to capture the stack trace. If I use npm run dev, it keeps the process running, forever, and I'm not able to, capture the stack trace. So you need to exit the process to capture the stack trace, and npm run build gives me exactly that. So I'm going to run this. So first of all, it adds Stackloop because it creates a folder Stackloop, the working directory, where it copies the content of the project into that working directory. And so it does all the operations in there. So you can see it actually captures it, and it adds the git ignore. So it's added, and it runs the application. It feeds the file in app layout, right? And then it feeds the file in layout rather, and it feeds the file in page.ts. And you can see files were fetched in the working directory. So it created the working directory Stackloop, and it's fetched the files in there. And now it's going to ask me, do you want to sync the files back to your root? Yes, I want to. So you sync the files back. So all done, your file has been updated. So back here, you can see it's updated. It added this fragment thing, and it created a backup. Then it updated it. So everything is back running. So let me try and run it again. So I'm running it again this time. Build. Exactly. So you can see code executed successfully with no errors. So everything is good. Let's look at the code. Before we look at the code, I want to quickly explain the architecture of an AI agent. So first of all, what's an AI agent? An AI agent is an autonomous system that is powered by a large language model. It can reason about tasks, and it can use tools to take actions and remembers the context to improve its future behavior. So the three main components of an AI agent is, first we have the LLM, which is the brain behind the agentic system. We have context. Context is it basically defines is where you define the goal of the system, the task, and what the system is supposed to do. That's the context. So you can, when you write your prompt, when you write your system prompt or your user prompt, all those pass as context to the LLM, that the LLM then uses to understand what the goal is for the system, and then it uses that its understanding to fix whatever issues you need it to fix. And then we have tools. Tools are functions that you've defined and that you've made available to the LLM, that the LLM can use to solve whatever problems, whatever the goal is that you define in the context. Now, we can use tools to get additional information, additional context to the LLM that it then uses to provide you a response and provide an output. So let's take a look at the code now. So let me show you all this working together in the code. So here's the code. So it's a CLI application written in Python, and I'm using the typer library here, which is a cool library that you can use to build CLI tools in Python. And when you do the Stackloop run command, so the application is Stackloop, it's called Stackloop. So when you do the Stackloop run command, it runs this particular function here, right? It's just one command that I have for now. So it runs this particular function, and when it runs this particular function, you can see you can pass in the directory, and it's optional. You can pass in the directory, or you can run it without passing in the right directory, and so it will take the root, like where you are running it. It will take whatever. It will take that as the root directory, and then it will run the stack loop command in that root directory. So when you run it, we display that welcome message in the console, and then we resolve the directory, whether you pass in the directory or we use the root directory. We get the environment variable. You must define the environment variable that is relative to the provider that you're using. If you're using Grok, you must provide the Grok API key, or if you're using Anthropic or you're using OpenAI, you must provide OpenAI or Anthropic API keys. So this is where we just read environment variables. You select your provider here, you select your model, and then the runtime choices. So the runtime choice, whether you are using Python, Node.js, Go, whatever runtime you're using, and then the script. So in the demo I showed you, I was using npm run build. So this is where we'll capture that script, and this is where we'll set up the section, and then the section. So basically, create a file, create a section config.json file, and then we'll pass in the runtime that you selected, the script that you selected, the root directory, and all that. We just put it in the config.json file, and this is where we define login. And then here is where we do the agent setup. Let me show you the agent setup. So in the agent setup, these are the providers that we have. And the reason why I just went with these three providers is because they have so for example, Grok has access to GPT-OSS, which is an OpenAI model that is optimized for tool calling, so for function calling, agentic development. And OpenAI, Anthropic, they have models that have been optimized for tool calling, which is the core of agentic development, because you use tools for to call, to get in whatever extra context that you need to solve the goal of the agent. So I'm just restricting it to just Grok, OpenAI, and Anthropic. Then we get the model. You can see Grok model. You pass in the API key, Grok provider, or you're using OpenAI provider, using Anthropic provider. And then we get the model, and then we pass in the model. So this particular class is from Pydantic. And so this is how we create an instance of an agent. We pass in the model, the name, and the output type. So I'm creating an output type of two classes, so output result and no result. So I'm just using union. So this tells the agent to return a class of either output result or no result. So there are two classes. And then I put a retry here, which is just a guardrail to tell the model, the agent, that the maximum retries that it can, like the maximum is 2. So you shouldn't try to, if there's a failure, you shouldn't try to retry more than 2 times. So here is the system prompt. This is where you define everything about the goal of the agent. Now, you can see how detailed my prompt here is. So when I wrote the prompt initially, the agent wasn't performing exactly what I wanted. And so I needed to be very explicit and be very detailed. Every edge case, everything. No, don't hold anything back. Be very detailed. And so the way I actually even achieved this was I took my original prompt and I went on ChatGPT and I just explained what I was trying to achieve. And ChatGPT just gave me this prompt. And so I just had to modify some things and just modify, a few things in the prompt, and I just kept it like this. So in your own prompt, you have to be very detailed, because that's how the agent gets to know what you are trying to achieve. Don't leave out anything that will make the agent hallucinate and just create random things for you. You have to be very, very detailed. All right, so that's how I create the agent. And then this is where I register tools. So I'm registering tools. I'm just using the agent, the decorator, the tool decorator, and then I'm registering just 3 tools. So I'm using the run code to the read file and then the fix file. So the 3 of them, the run code is where I run the application. So remember we captured the script and the directory. So I pass the script and the directory into the context of the agent. So I pass that in, and then I provide the context to the run code operation. You can see I provide it here, and then it accesses that script and it accesses the path. And then, I pass in the script and the work directory, and then I start up a sub process, and then I run the script, and in the work directory, I run that, and then I capture the content, the stack trace, the standard output and the standard errors. All right, so that's run code. And then read file, we basically read the content of the files that have errors and send it back to the LLM. And the LLM then generates the fix. And then in the fix file is where we do the updates. So let me just show you that fix file operation, update content. So first of all, create a backup of the original file, and then we write the new content to the file. So this is how I set up the agent. Now let me show you how we are calling the agent. So I do get the agent instance, and then get the agent here. Then I call this run agent operation. So in the run agent operation, this is where I call data.agent.run. So this run, I'm running the agent in async mode, right? So I define the dependency to the context here, right? So it's of type. This is what my the agent context would look like. You have script and you have path. That's all I've defined. And then I pass in the script, and then I pass in the working directory as well. And then, so I also define something here, which is the usage limit. This is just guardrails, to tell the agent, don't make LLM calls that are more than 15. So the maximum you can call is 15 calls to the LLM. Right, so it returns either an instance of output result or no result. And then yeah, these are the other code in here that I just used to, you know, decide if you want to, like, for example, after we've done the update in the working directory, if you want to sync it back to the root directory, this is where I show that prompt and then do all the updates and the things that we need to do. So this is the code. I'll put a link in the description to the GitHub repo where the code is, and I'll put a link to the Stackloop library in the description as well. I'll put a link to Pydantic library and maybe any other resource that you might need to build your own agent. I'll put everything down in the description below. All right, so that's the video on building an AI agent. Thank you for watching. Do like and subscribe to the channel, and see you in the next one.